So peeps, another day and another breakdown video for you beautiful people. So what we got here is our pass washer, and as you can see by the HMI, we've got two faults on here, fuse tripped and a VDF tripped. And I'm going to go through this step by step, how to test it, how to read your electrical drawings, because some people think they're scary, but they're not. Now, there's some people that are going to be out there and they're screaming, thinking, what's he doing going into a panel when it's a little live? All you got to remember is I'm trained. If you're not confident, you're not competent, don't be going inside a live panel. But you can't fault find unless you actually have the machine itself up and running. Now, as you can see, most of these modern day components, all of the metal parts are all shielded, and I'm going to use my wand as a pointy stick. I'm not actually going to put my finger, because I live by don't put your finger where you won't put your dingleberry. So let's get into this. As you can see, I'm visually checking, and I can actually see this overload is tripped. So that gives me my first instinct of where to be looking at. So I'm going to be looking for my electrical drawings, and you want the most up to date. And as like a blue Peter moment, I've printed these off to make it a bit easier to explain. Now, this labelling on these components, that's where you want to be looking at. This is your first telltale sign. So you see you've got 63 Q2, so that's telling me page 63, section Q, and then that's all to do with these bars on the side and top. So that's going to tell you where to be looking on that page 63. And if it wasn't tripped, we'll go into that as well. But as you can see there, that's showing my tails coming into the overload, where they're coming from, the overload itself, the ratings and the auxiliaries, and where the tails are going off to next. So with that auxiliary, if this wasn't tripped, that's what I'll be checking next. Because as you can see, this is on a ringed common 24, and then our signal going to the PLC is not normally open, because everything's safety is going to be normally open, because you're constantly looking for that signal, and then when it trips, that's going to give it. So, how would I know where that signal's going to on that PLC? Now I can tell that by looking at the drawing as well, because that cable's going up to that PLC, but as you can see there's hundreds in there. So how would I know? By looking at the drawing, and you can see the auxiliary on the side, and you see them little numbers, that's telling me page 131, section 1A. So I look at the beginning of the page, and then you can see this is my input coming from the overload. And that's showing you your input, where it goes in on the card. So next, because I know it's tripped, I'm going to be looking back at page 63 Q2, looking at where it goes to next, because it goes to that dryer up there, as we can tell by the HMI on the screen. If we go back to the electrical drawings, now if we look at the bottom of the page where the tails are going out, and they've got the arrows pointing down, that's telling us to go to page 96, 2A, 3A and 4A. That's where them tails are going to come in and what they're feeding. So if we go page 96, now that's showing, we'll see in a minute, the top of the page, we've got our tails coming in and what it's feeding, and this is feeding the VDF. And as you can see in this cabinet, they don't correspond with the label markings of this 96 U2. And also this page is telling us something else. Main cabinet is that dotted line at the top, so everything that dotted square area is in the main cabinet, as it says. And then there's a second box that says dryer, and that's a direct drive. So this is showing us that this VDF is actually up there on the dryer itself. That's what we can't. So we've got our common 24 coming in. And again, we've got our safety and our healthy switch on, they're normally open. So if this was to fail, it's just going to open circuit. And that shows you where the junction is. And then that's our input to the PLC. As you can see, that shows you what module to look at and what your cable and your ident. So you want to be checking for your 24 at all of the joints or terminals to make sure you've got no break in the cable or anything like that. And as you can see, that cable marking said 305, so that's our, we want to be checking that we've got 24 there, and then tracing it back to the PLC. And as you can see, this is in the dotted area that says the main cabinet. And here it is itself, the direct drive close inspection, it doesn't look that bad, apart from you can see that witness mark where it looks like it shit itself. To be fair, it looks like Tom's the tank that smoked 40 a day for 40 years. It's blowing its guts. That gland should have a cap on it, and it's proper blown up. So to open it up, on first inspection you can't see anything, and then deeping down we've got a voltage step down that's absolutely blown itself to pieces. And here's the terminals that once the VDF's off, and I'm going to check now the windings of the motor, make sure it's not the motor that's actually caused this issue. So I'm going to be doing an IR test on it, on resistance insulation. So first I'm going to be doing down to phase to earth, making sure that we've got nothing touching the shell of the motor itself. And then I'm going to be doing phase to phase. So obviously I'm going to have to strip out all of the phases off the terminals. And I'm going to be going end to end, and end like each phase. 2 of them are going to be a short, because that'll be the 2 ends of the windings. But then I want to be getting, and remember, you want to be getting at least over 100 mega ohms for a good reading. And as you can see, these are all well over 500 mega ohms. So the motor was fine itself. I even took the motor cover off and it sped up freely. So there's no actual cause. It was just a component malfunction. So it's going to have to be a brand new VDF, because you don't know what else is burnt out. There's our dead short, because that's the 2 end of a windings. And if it's has to help someone, don't you forget, beautiful people, you're all legend approved.